Aloha and welcome. In this video, we're going to be talking about linked lists. So let's go ahead and open up our textbook here. The linked list, it comes from the Java collections framework that defines a collection of ordered elements, in other words, a sequence. You can do all kinds of things on these. There's methods for adding, modifying, and removing the elements. It's an ADT, which is an abstract data type. It's implemented as a generic class that supports different types of elements. So you can have linked lists of integers, strings, doubles, whatever you want. The way you get to use this, you're going to, at the top of your code, you're going to put in import java.util.linklist, and that's going to enable to use the linked list within your program. So a couple of things about this. There's methods for adding. There's methods for removing. For adding, it's actually overloaded, so you can add in to the end of your linked list, or you can go and add to a specific place within your list. So we're going to take a look right now at the participation activity. So in this participation activity, you see we set up a linked list of strings, then we add in gamma, Penrose, Hawking, and then we go in, and this is in the 0th position, 1 and 2. And then we're going to go over to 1. We're going to insert here at Penrose. But when we insert, we're not doing anything to Penrose. All we're going to do is we're going to open up a space between Gamal and Penrose. We're going to put in green. So then we'll have, this will be our 0, 1, 2, and 3 position. So when we do this, it says the add method adds an element such a string to the end of the list. So it's going to go ahead, create it. That's list number 1. Goes and adds at the end of the list at Penrose. Goes and adds Hawking to the end of that list. And now it goes and says, well, the next step is going to say add 1. And then it's going to go to that index. It's going to go up here to 0, and it's go down to 1. And then it's going to insert in right here. It's going to put green in at 1. And now you notice that your list is 1 larger than it was before. So it's gone from being 3 elements to 4 elements. And we did not overwrite Penrose. We inserted it in between. So the add here is actually doing an insert where we're shifting everything down. For our participation activity here, given the following code that creates and initializes a linked list, so we look at string words from file. We've got the file is the term. Okay, great. At what index does the following statement insert the word end? So this is asking you to understand aspects of linked lists that we just talked about. So we're doing an add, and adds, as we know, are going to insert at the end if it doesn't have an index listed there. So what's the index of that? It's going to be 0, 1, 2, 3, 4, and then 5 after we create it. So we're going to have a 5 here. So these are just going to be asking you like what to do. Like we add in it 4, 0, 1, 2, 3, 4. If we add it in here, it's going to come between the and term. So big would come between those two. So anyways, use your knowledge that we just gained and answer these questions. So some common linked list methods. We've got the get method, and that's going to return the element at a specified index. So when you call in get, you're going to give it a number, like let's say 1, 2. You want the first element, it's going to be 0. So to access the specified list element, the get method will start at the first list element and then traverse the list by element until the specified index is reached. So when you're doing like player name.get of 3, it's going to start at element index 0, and it's going to go until it hits 3. So it's going to traverse each and every one of those. So in your head, you should be thinking, wow, that seems kind of inefficient. So yes, you're absolutely correct. So we'll talk about that a little bit later. But we also have the set method. The set method is going to replace the element at the specified location with an element. So unlike add goes and it inserts and it pushes everything down. Set is going to that location and just overwriting it. So you're not going to keep what was left in there. So if we look at our participation activity here, we hit start. We're going to go and search the linked list to return the element at the specified index. So notice we're going down to 2, so we're going and traversing it every step. And then once we do that, we're going to set 2 to Sagan. So we're going to go in, again, we're going to be traversing this again to get there, and then we're going to replace it. And if we want a print line of that, you guessed it, we're going to have to go through it and traverse it all again to get to that second one. So as you can see, this is inefficient. So we're going to talk about the remove method. The remove method removes the element at the specified index. So if we say, print line get one, or then remove one, well, let's just go ahead and watch. So the remove method removes the element at the specified position. So it's at 1, this is 0, this is 1. So again, it has to traverse down to green to get it. So it displays it, and it's going to remove it. So it's going to go traverse down there, remove this element. Now they relink this way, and now it's going to get the one in position 1 again. So it's going to go and traverse the list to get to that, which is on a list of 0, 1, or 2 elements, that's not bad. But if you've got 1,000 elements, you can see how inefficient that's going to be. It's going to be really time consuming. So some of the methods that you can use on the linked list class are listed here. So we've got get. Get is going to return the element at a specified index. The set, as we mentioned, it's going to replace something at the specified index. So you're going to have set, the index, and then the value to be replaced, or the value that is you're going to replace the existing value with. And then we have add. Add is overloaded. So you've got 2 different forms of it. You've got add, where you're just telling it the element, and then it's going to stick that at the end of the list. And again, we're increasing the list the size of the list by 1. Then you've got add, where you're telling it the index and what to put in there. And that is going to go down to that index, insert it, and then what was down below it gets pushed down. So you're going to have, again, a list that's 1, it's increased by 1 in size. The size method here returns the number of elements in the list. And then we've got remove, and remove is going to remove the element at the specified index. Or you can tell it what the existing element is that you want to delete, and it will go and find that in the list. It'll find the first occurrence of it. So if you have, let's say, the word cat in there twice, and you ask it to remove cat, it's not going to remove it twice. It'll just do the first one. And each of these operations that for remove, it's going to decrease the size of your list by 1. Then we have our participation activity here. Given the following code that creates and initializes the linked list, we're going to add in these 3 values. It says complete the statement to print the first list element. So we're going to look at that. So it wants to get the first list element. So accelerometer values, we're going to be looking at a get of 0. And they've got that input in our, so we just want to get the first one. So we do a get of 0. And then go ahead and answer the rest of these questions using the knowledge that you gained up above. So now we're going to talk about iterating through the list. So as we saw before, for a linked list, it's very inefficient to go and do the get and set and things, because it has to go through every element to get there and then do what it's going to do. So what we do is we use something, well, actually, let's show the inefficiency real quick, which we've kind of observed already. But if we look at this, the get method always traverses the list sequentially from the first element to the desired element. So over here, we're setting up the author name in the author's list. Then we're going to go ahead and set an index. We're going to add our 3 items here. And now every time we go to get like item 0, let me double speed this. So it'll grab gamma, and then it'll go and print it out. Then it's going to go to the next item. It goes to 1, it gets green, assigns it here, goes to print it out, then it's going to go. So every time it's going to have to traverse each member of the array. So this is highly inefficient to do it this way. So anyhow, so to improve this, they've got to efficiently iterate through a linked list. You don't want to be doing the way we do. We want to keep track of the current position in the loop without using an index. So a ListIterator is an object that points to the location in a list and provides methods to access an element and advance the ListIterator to the position, next position in the list. So we have basically a pointer into the list that kind of keeps track of where we are. So ListIterator method returns a ListIterator object for traversing list. So we can just import java.util.listIterator, and that gives us the functionality that we're going to need to use for this. So if we look over here, we've got a demo of that. So you'll see that we're setting up a linked list of string here. We're setting up the author name. Then we're going ahead and setting up our ListIterator. Then we put in 3 different values into our list here. And then we're saying, oh wait, hold on. Sorry. Up above, we just set up our ListIterator. We didn't actually initialize it. So we had initialized that by calling on the authors list that we created, the linked list object, and we're calling on the ListIterator function that returns, or method, and that returns the ListIterator. So now that we've set that up, we're going to go ahead and we're going to use the hasNext. hasNext just says, hey, is there another value in here? It comes back as true in this case. So after we've identified that, then we're going to go ahead and we're going to say next. And what next does is it returns the next value in there, which is the first one, gamma. Now you notice that we have a pointer that's pointing between gamma and green here. So what this is going to do is as it's going through this list, it's going to pull the next item. But as it does this, you'll see that the pointer is between the items. And once it's moved past that, like it is right now, it's going to move pen rows down there, and you'll see the pointer adjust to after it. So then hasNext is going to come back as false. After it comes back as false, then you're done. So you get kicked out of the while loop here. So this is more, because you're keeping track of your position as you go through, you don't have to repeat the wheel every time and go and traverse the whole thing. So this makes it, much faster. So thing to keep in mind is the ListIterator, it's really a pointer that points between 2 elements of the list. When you first start out, it's going to be pointing before the list. So if you have 2 elements, let's say 5 and 6, they're going to be in position 0 and 1. Your position is really right before the 0. So when you say next, it'll grab that next value. Or if you say hasNext, you'll see that that first value is it is there, so it returns as true. So a good practice is to call on the hasNext function before you actually try to access the next one. And I'll leave it as an exercise for you to find out what happens when you don't do that. So we'll go ahead and look at down here, the ListIterator set method replaces the last element accessed by the iterator. For example, the element returned by the prior next call. So we're going to take a look at this. So in our participation activity, ListIterator set method replaces the prior element accessed by iterator. We hit start, and we're going to look over here at our pointer. hasNext is true because there is a next one. So then it goes and it grabs that, puts into author name, then it converts that to uppercase, puts that into the uppercase variable here. Then it's going to go ahead and it's going to set that value because that was the last thing we pulled out. So then it's going to say hasNext, it's true. So now we proceed to get green. We put that in author name, we capitalize it. And after we've capitalized it, we're going to take that, put it into the uppercase name. Then we're going to take that and push it back up using the set. So we're going to set that, and the set is operating off of the last one that we pulled using the next command. So we keep on doing this until we're finished. So it's gone ahead and replaced everything there. And then it finally says false because we're now below here and there is no next. So then it kicks out. So all the strings in the list have been replaced by their uppercase versions. So when you print it out, it comes out just like this. So there's a number of methods that ListIterator has. The first one is next, which we just used. That's going to return the next element in the list, and it moves after you've returned that. it's going to move the pointer to the right before the next element. So if we look up here, these are really good examples, by the way, over here on the side. So you've got 3 and 4 right after you've instantiated the list. But then when you get the iterator itself, your pointer is going to be pointing right before the 3. So if you use the next function at that point, it's going to give you the 3, and then it's going to move the pointer in between the first and the second elements there. So the next index is going to give you the index, in other words, the position. So in the beginning, you've got next index, and it's going to say 0, your next one, because we're not at the 0 point right before it. So the first one, the next index, is going to be the 0. And then the next item, if you want to say next, it would grab the 3, and it would return the 3, and then it would move it to between 3 and 4. So that's how that works. Wait, I think I may have just misspoken a second ago. The next index tells you what the next index does. It doesn't actually advance it. It's next that's advancing it. So next is actually going to consume the 3, return it to you, and then move to the next one. So yeah, so then if you were to call next index, it would return a 1, but it would still be in the same place. Sorry for the confusion there. So previous works kind of similarly as you would expect. So we have 3, 4 to begin with as our elements. When we say we go ahead and create the list iterator, it's looking before the 3. So then we say next, it's going to return the 3, and it's going to put our cursor in between, or our pointer in between the 3 and the 4. So if we now say previous, it's going to return the previous value, which is the 3. And then previous index, as you would expect, if we had our position in the iterator all the way after 5, we said previous index, it would be 0, 1, 2. So to return a 2 there. Then if we said return the previous element, that would be this one right here, the element before the pointer. So it would return a 5. And then after returning that 5, it's going to move the cursor between, or the pointer between 4 and 5 right there. Then if you say previous index, the previous index at that point is going to be the 0, 1th index. So it's going to return a 1. Then hasNext, it's a Boolean. It's going to return a true or false. If you have something after the position you're at, it's going to be true. If not, it'll be false. Then hasPrevious works as you'd expect. It's going to return, like here, if it's in between, it'll return true. If it has something before there, if it's all the way at the beginning, it's going to return a false. And then, yeah, so that's what you need to keep in mind. The add element, so the add, it adds the new element between the next and the previous elements and moves the list iterator after the new element. So if we look up here, we see that we've got 4 and 5. It's pointing right before the 4. So if we say add 3, it's going to add 3, and then it's going to move the cursor after that 3. So now we're between the 3 and the 4. If we do another add, it's going to add 11 in here, and then it'll move after the 11, and we're still before the initial 4 that we were at before. But all it's going to do is it's going to keep on adding to before the place that we were at. Then remove is going to remove the element returned by the prior call to next or previous. So if you're traversing through there and you use a next, and then you want to delete that one, so you call next, it returns like 4 here. And it's like, oh, I want to remove that one. Then you can just call remove. It's going to remove 4. And now your list is 1 shorter. So yeah, so then it works whether you're using the next or the previous. So if you were to do previous to that point, you grab the 3. And then if you called on remove, it would remove the 3, and it would just be left with the 5. And then set is going to replace the element that was returned by the prior next or previous call. So kind of like the way your remove worked, except that you're setting the value there instead of removing the value. So if we're over here between the 3 and the 4, and we do a next, it's going to give us the 4. But then if we were to do a set 44, it would replace the 4 with the 44. If we did another set, it would replace the 44 now with the 21, as they did here. So yeah, so just keep in mind that the set is going to replace the value at the it's going to replace the value that you just came up with using the next or the previous. So then we have a participation activity here. Answer the questions given the following code that creates and initializes a linked list and a list iterator. for every question, assume that the list iterator is located before the first list element. Okay, so we've got a number list of integers. We've got our number iterator. We're adding 3, 1, and 4, and then we're going to say, oh, then we're instantiating the list iterator. So what does number iterator dot hasNext return the first time? So if we look at that the first time, we've got 3, 1, and 4 in there. So if we have a hasNext for number iterator, because number iterator, after we've added that, it's going to start before the 3. So hasNext will be true. And then you can answer the rest of these questions too, looking through all that. The next part that we have is, oh, this is a nice tricky one. You really need to pay attention when you're doing this because this will be a little bit disheartening. So click on start. You need to read the code, figure out what it's going to do, and then print the output. And this is a royal pain because you've got add statements here, then you've got the overloaded add, and you've got the set, and you've got a remove. So what you need to do is sit down and really look at what your indexes are and make sure you're doing the same thing. Then over here, you notice that you're printing out the letters that are left or whatever, but then you have to print a print line at the end. So don't forget that last enter. So these will all be together. This one says you're going to enter. And this is a pain. I have to pull out the old pencil and paper to do this. You can use VS Code and kind of write everything down there if you wanted to. But for example, this one right here, actually I need a cleaner sheet of paper than that. But if I was to do this one, we're going to write down, so we're entering E, F, G, H. So E, F, G, and H. I wish I could show you this. Actually, let me go ahead and I'll grab the code here, and I will meet you over in my VS Code editor. So I'm going to stop the share here, and I'll share my code editor. And in here, I know I'm putting in the code that they have us do. So what we're doing is we're creating E, F, G, and H, and that's the 0, 1, 2, and 3 place. So what we're going to do first, after we've got the E, F, G, H, is we're doing we're doing add into the second position. We're adding the value I. So the second position is this one right here, and we're adding I. But when we add, we are simply adding one in there, and now we have a new index here for the last element there. So we've added the I, and now we're going to set position 4. So if we look at position 4, that's right here. So H, we're going to overwrite H and put J there. So it looks like this now, E, F, I, G, J. So we take that, and I hope I haven't done this so fast that I'm not really paying attention. But let me go ahead and go back to our page here, and I will take a chance on embarrassing myself. So I think we've got E, F, I, G, J, and we have to print that enter at the end of it. So we'll do a check real quick, and I have missed it as I thought I would have because I've gone too fast here. So let's take another look at it. So E, F, G, H, and we're doing I. Oh, that's why, because I ignored the fact that we had to do the J there. We had to remove the J. So if we look at that, we had to remove the position 4, 0, 1, 2, 3, 4. Yeah, so let's go ahead and click on next here. And this is the thing, it's going to give us a new problem here if we click on next. So we'll go ahead and I will copy all this and take it into the editor again and reshare it, and we'll hopefully, yeah. So this is tedious stuff. So just, don't be dismayed if you don't get it exactly right the first time. I am going to redo this. So we're adding in letters A, then B, then C, then D. So we've got that. And before we can do that, let's go ahead and put our indexes in 0, 1, 2, and 3. So then at position 2, we're adding in E. So position 2, this is 0, 1, and 2. So in position 2, we're adding in E here. So when we add in 2, we're going to, hold on. So we add in E, and we've expanded our thing by 1 here. So we've got a 4th position there. So we've added that one in. Then we're going to set 1 to F. So what we're doing is we're changing B to F here. So we've got A, F, E, C, D. Now we're going to remove the element at 3. So when we remove the element at 3, we're removing the C here. So we've got AFED. So AFED should be the answer. And I will go ahead and share my screen with the here. Yep. So what's that? AFED. Let me do a quick check to make sure AFED. And don't forget your print line because it will complain about that. And that is correct. So go through here slowly, like I didn't do in the first one, and just make sure that you do it step by step because it is tedious. And you need to make sure that you're at the right place, with the indexes and everything. So then we have a final challenge activity down here. Declare variable width list as a linked list of integers. Read integer numwidths from input, then insert numwidths integers with values from 1 to numwidths into width list in reverse order. So you're going to go ahead, you're going to set up your variable declarations down here, and then you're going to, what do they want you to do? Declare variable width list as a linked list of, okay, so what I want you to do with this, when you know you're doing a linked list, you can, of course, do it from memory, or you can just go and grab stuff that we already have and take that and put it in here. So you can, oh wait, we have to hit start. So then you come over here, cut and paste, and then you just change your declare width list. So list. So then, what is it? Integers? Yeah, integers. Great. So you've got that. Then you're going to read integer numwidths from input. So we go over to here and we type in. So we've got our scanner defined as C, SC, and R. So our num widths is going to be equal to, I think it's C, SC, and R dot next int, I think is the proper one. So we read that in. Then insert numwidths integers with values from 1 to numwidths into width list in reverse order. So if they put in 4, then we do 4, 3, 2, 1. Okay. So we can do that. So we would set up or let's see, I equals num widths because we're going to be going from that one down to 0. So I equals num widths, and we're going to say, well, I is greater than 0. Wait, hold on. We're going from 4, and we're going to go down till, so we have number, yeah, we want to be greater than 0 here. This is always the confusing part. I equals greater than 0, then we're going to do I minus minus to decrement it, and then we're going to, so now what we're going to do is we're going to print it, or not print it, we're going to be adding to our width list here in reverse order. Insert integers into right now with values one. Okay, yeah. So we're going to say with list dot add because add is going to end it to the end. So yeah. So okay, yeah. So we're doing an add here. We're just going to put in the I of it. I believe this is correct. So as we're doing it, we're just doing the integers going down. So we're starting at, let's say 4. We do 4, and then we'd decrement, we'd add in the value of 4. Then we would go decrement it. It's 3, it's still less than 0, 2, 1. So that should get it right there. Then we hit check and get the error messages. Then we learn from our mistakes in the error messages, except, whoa, it didn't mistake. Yay. So you just have to be, you have to read your instructions here and understand what it translates to. The reverse order here is a little bit tricky because instead of adding it in one by one, we're going to have to reverse it. And that means that instead of doing a for loop like we do here where we're going up, we're going to be doing it down. And you want to be very careful because you don't want to set up an infinite loop. So you want to make sure that when you do this, you have you have a decrement going on here because you're going to start at some positive number, and then you're going to go, you need to decrease it. If you're checking for I is greater than 0 and you're accidentally increasing here, yeah, not good. So go ahead, work on the other 2, 3, and 4, and yeah, if you have any questions, just reach out, let me know. There's a note down here at the bottom about linked list versus array list. They're both ADTs that we mentioned, abstract data types. So, the question is, which should you be using? And it really comes down to your implementation and what kind of task you're doing. So it talks about how the linked list is typically, it does faster element insertion and removal at the list end and middle if you're using a list iterator. But the array list offers faster positional accesses with indices. So in this one, we use the linked list class, but the examples can be modified to use either one. So anyhow, if you have any questions, feel free to reach out. Be happy to help set up a Zoom session or answer an email, whatever. But anyway, take care, and I'll see you in the next video. Aloha.